Today we're going to go over the Unit 6 test review. This is your last test for this 9 weeks. I will try to go through and do one of each kind and then go back and work through the rest. So these first first 5 are just solving equations. So we are trying to get the variable by itself. Normally we draw our line and then we make adjustments to it. So since the r is on this side, I'm going to move this 8 to the other side. So right now it's positive, so to undo that positive, I subtract. Negative 27 minus 8 is going to give me a negative 35. I'm going to divide both sides by 5, and r should give me a negative 7. Okay. On this one, this had a variable only on one side, whereas on number 2, if you look, there's a variable on both sides. So I'm going to go and draw in my line. Typically, I locate my variables and then I say, well, which one is bigger? Since the 6w is bigger, I'm going to move the 4w to that side. This just avoids having any negatives on my variables. It really doesn't matter. If you'd rather move it the other way, you can do that. So 6w minus 4w is going to give me 2w. Now I still have this negative 13 right here. I'm going to go ahead and add that to the other side. So I get 23 equals 2w. So then my last step will be to divide by 2. And I get, 11.5? You can leave it as 23 over 2 if you want, but if you would rather go ahead and change that into a fraction, you may do that. Into a decimal, you may do that also. Alright, this one just has fractions, but you know that your calculator does fractions, so I'm going to skip that one for now. Number 4, you do have a set of parentheses, so before you can do anything, you need to distribute what's on the outside. So this 3 is going to go to the n and to the 2. So I end up with 3n plus 6. Once it's right here, it's exactly like number 2. I have a variable on both sides. So I have 6n and 3n. So 6n is larger. So I'm going to move to the 6n. So I'm going to go ahead and subtract that 3n. So 6n minus 3n gives me 3n. And then I still have this 6 over here. I need to move this 5 now, or this negative 5, so I'm going to add it to both sides. And my last step would be to divide by 3. On this one, I'm going to go ahead and leave it as a fraction, just because when I divide that, I'm going to get a repeating decimal, so I'm going to leave it like that. Alright, once we throw in the absolute value bars, this changes how we solve the equation. It changes the initial setup, I'm sorry. So r plus 5, remember that whatever I get in here could be positive or negative. So technically, this absolute value could be a positive 12. So I'm going to say, well, r plus 5 could be 12. But everything inside there could also be a negative 12. And then once I took the absolute value, it gives me positive. I have to set both of these up and solve them. So I'm going to subtract the 5, end up with r equals 7. Subtract the 5 over here also, and I'm going to end up with r equals negative 17. Now on these absolute value problems, you really need to check your answer to make sure that it works. So I'm going to plug in the 7. So 7 plus 5 is 12. So is the absolute value of 12 12? Yes. If I plug in negative 17, do I get 12? So negative 17 plus 5 is a negative 12. Is the absolute value of negative 12 12? Yes. So both of those solutions work. On number 7, it's still an absolute value, but I need to move this 4 first. So I'm going to divide both sides by 4. When I do that, my absolute value is still a minus 6, and then 16 divided by 4 is 4. Once it's set up like this, it's just like number 6. So a minus 6 could be 4, but a minus 6 could also be a negative 4. And then I'm going to solve both of these individually. Now remember, I need to go back and check these. So 10 minus 6 is that 4. So the absolute value of 10 minus 6 is 4. So absolute value of 4 is 4? Yes. Now over here I'm going to do 2 minus 6 to see if that gives me 4. 2 minus 6 gives me a negative 4. But is the absolute value of negative 4 4? Yes. The only problems that you really need to be careful of are the ones like this. So I have a variable on the other side that's not inside the absolute. These are the ones that you really need to make sure that you're checking those solutions, because typically one of them does not work. So on these, the n plus 5 could be 2n minus 9, but the n plus 5 could also be a negative 2n minus 9. I still need to solve these. So variable on both sides, I'm going to move towards the larger. I'm going to add my 9. Okay, so there's one of my solutions. Now over here, I need to distribute that negative through to both of those. So I have a negative 2n, and now I have a positive 9. Now I'm going to move the 2n because that's my smaller. And then I subtract my 5. And then divide by 3. Now these are the ones that you really need to check the answers, because the likelihood that one of them doesn't work is pretty high. So I'm going to go ahead and plug my 14 in right here. And does that give me the same as plugging it in on the outside? So 14 plus 5 is 19. 2 times 14 is 28. So is the absolute value of 19 19? So that one works. 4/3, I need to go ahead and try that one. So I have 4/3 plus 5 equals 2 times 4/3 minus 9. Without doing all the math, I can look at this. 4/3 is a little over 1. Well, 2 times 1 is still going to be around 2. 2 minus a 9 is going to end up giving me a negative number. Can my absolute value be a negative number? No, because by definition, if I've taken the absolute value, it should be a positive number, which means that 4/3 does not actually work as a solution. Alright, so 9 and 10 are similar to the last one, so I'm going to go ahead and skip over those. Alright, 11 through 14. You are writing the inequality for each graph. So I can look right here, and I know that this is starting at 2. And then it's increasing, so I know that it's greater than 2. A closed circle means that it can also be equal to, so this should be x is greater than or equal to 2. On this one, I'm starting at a negative 1, but this time you're going smaller and smaller, so you're looking at less than a negative 1. Open circle means not equal to. When I have two different ones, I'm going to have two separate inequalities, and I should have an or in between. So if I look at this one, I have a negative 2, and then it's everything below it. Closed dot means equal to. Over here, it starts at 4, and it's taking everything above it. Closed circle means greater than. So these are my inequalities, and I have an or because I have this gap in between. Now here, because I am actually bounded on both ends, I only have one inequality. I have a negative 5 all the way to 1. Open circles on both means it's just less than and greater than, not an equal to. Alright, on 15 and 16, you are taking the word problem and actually putting it into an equation. So the product of 1 and a number is less than 8. So the product of 1 and a number is less than 8. So remember that product means multiply. And a number is going to be our variable. So then we say 5 less than a number is at least 60. So 5 less than that just means subtract, is at least 60. So it's going to be at least 60. All right. When we are solving inequalities like this, we solve them just like regular equations. The only thing that we have to be careful of is if we multiply or divide over the inequality by a negative, that will reverse the direction of the inequality symbol. So you just have to be careful and make sure that you are watching out for that. But otherwise, I solve it the same way. So I'm going to move my 8 to the other side. So 24 minus 8 is going to give me a 16. Right here on the very first one, I'm going to divide by a negative 4. So when I divide by a negative 4, that reverses that inequality. 16 divided by negative 4 is a negative 4. When I go to graph that on the number line, I want to put my value in the middle and just do a couple on each side of it. It's greater than or equal to, so that means I'm going to put a closed circle. And if I'm saying it's greater than a negative 4, I'm going to pick everything to the right. On this, we just have to solve two separate inequalities, and it's going to end up looking like this once I've graphed it. So I'll solve the one on the left first, so I'm going to subtract 4. So m is less than 1.5. Now I'm going to solve the one on the right. 9 divided by 3, so I get m is greater than 3. So I need to put both of these numbers on my number line. So 3, and 1, we'll put 2 here, we'll put 1 there, so 1.5 is right in between. It's just less than, so open circle, and to say less than would be to go to the left. It's greater than 3, still open circle, and everything to the right. 19 and 20 are the same. The only difference on 19 is that they are put together as one, and so when I get my solution, it will be bounded, a lower bound and an upper bound. But I still do this the same way. When I subtract the 3, I've got to subtract it from both sides. When I divide by the 4, I have to divide everything by the 4. So then I have my negative 2, my 4 is just open circles because it's just less than, and then bounded in between. Okay. So 20 is going to be the same idea as number 18. You're just going to solve them separately and then put them on your number line. Now 21 and 22, these are your absolute value inequalities. So because it's dealing with absolute value, I still have to set up two separate equations. The difference on absolute value inequalities is when I set up that second equation, that negative equation, I reverse the inequality symbol. So p minus 14 is less than or equal to 19. Okay, so I don't change any of the symbols when I set it equal to the positive, but when I make this the negative 19, I reverse that inequality. Once I've done that, I still solve these the exact same way. So I'm going to add 14. So I get 33. Still the same over here.